Okay, welcome everyone to the third live session for the course Introduction to Internet of Things. So, this is your opportunity today to ask any question that you have, and so as I said before in the previous live sessions also that the first thing that is very important is that before you ask a question, whether you have gone through the materials, right. So, I would be happy to answer any question that you have, but it should not be the repetition of what is already covered, right. So, if you have any question on based on what has already been covered, and if you have already gone through it, then you could ask any question, or you could even ask generic questions of any kind that you may have. Is there any question so far? So, we are waiting for the questions to come. So, until you write your questions, so let us have few discussions. Now that you have lot of ideas about IoT, the different aspects of it, and how to build small prototypes, what are the different applications of IoT, now that you have so many different ideas, and what we have done is we took enough care to ensure that even if it is an introduction to Internet of Things, we have taken enough care to ensure that you get a breadth of knowledge of different aspects of IoT. And so basically when we talk about any IoT based system, whether it is development of a small prototype or a large scale implementation, few things are very important. One is the sensing. So, at the very bottom of any architecture on IoT, as you have seen that there are so many different types of proposals about what would be the architecture of IoT, right, because there is no one standard, there is no one architecture defining IoT. So, one of the most crucial, the core aspects is to have adequate sensing mechanisms. So, what sort of sensors? It depends on what problem that you have in hand. So, different types of sensors could be used, right. So, if it is for environmental monitoring, you have certain types of sensors that will be used. If it is for health monitoring of patients or humans, you have certain other types of sensors that will be used. If it is for agricultural purposes, again in agriculture also what you want to do, if it is for, let us say, monitoring of water parameters of a field, then you have certain things to monitor, like that. There are so many different aspects. So, sensing basically the choice of the sensor depends on the type of sensing requirement that is there for a particular application that is going to be developed. So, sensor, and along with sensor you have what? Actuators. Actuators means like based on what has been sensed and making sense out of that data, that means that trying to derive meaning out of the sensed data, you get something, and then based on the results maybe you want to take certain action. So, that is that actuation. So, there are different types of, in the lecture on sensors and actuators I have covered different types of sensors, different types of actuators, and their roles. So, basically sensing and actuation, they go hand in hand, and together what you have is the sensor and actuator network. So, and that network, so basically you have different sensors. These sensors are part of sensor nodes. So, sensor nodes, actuator nodes, and all of these basically they are going to be connected together, they are going to be inter-networked. So based on the type of, again, the application requirements, the choice of the particular communication mechanism, that also is decided. So what type of communication will be used, whether it is going to be Zigbee, whether it is going to be Bluetooth, whether it is going to be Wi-Fi, like that, so there are so many different other possibilities that are also there, or whether it's a combination of few of these. So you have the sensors and the actuators, you have based on the data that is received, you have to do something with the data. So sensor, actuator, the communication network, and then you have to make sense out of the data. So for that, what you have to do, you have to use the data, you have to send the data somewhere for further processing. So for that, you can use servers. You could, if it is a very simple application, it could be even simple workstations, servers, server farms, cloud, or even nowadays people are talking about doing some of the computation at the close to the source, that means close to the sensor devices, so, and rest of the others at the cloud. So we could have a combination of these, a fog computing or an edge computing kind of mechanism through which you would be able to handle the data, and the data will have to be stored somewhere as well, right? So whether it is the cloud, whether it is the server, whether it is server farm, as I said, it has to be stored, it has to be processed, right? So all of these basically come hand in hand, they have to be put together. And nowadays people are also talking about use of machine learning techniques, right, everywhere, and in IoT also machine learning is very important. The reason is that for that making sense out of the data, you need machine learning. So how you are going to, based on the past historical data, for instance, how you are going to predict what might happen in the future, this is one use of machine learning. And there are different other uses as well. You might want to classify the data into different types and maybe then take certain action, right? So there are like this, there are so many different uses of machine learning. AI also comes into picture. The reason is that there are so many different ways AI comes into picture. One of the ways is basically the use of robotics, right? So robotic devices, robots, robotic network robotics, swarms of robotics, swarms of robots, all of these are very much important for basically powering. So everything, sensing, network, sensing, communication, network, then this thing, your cloud, fog, then analytics, that means machine learning, artificial intelligence, all of these basically they work hand in hand, and all of these are like considered to be pillars for development of IoT, right? So this is the core thing, and then rest of the things are like as I have taught you, like use of Arduinos, Raspberries, and many other open source hardware products, and like this there are different choices of sensors, actuators, etc. So how you can use them together, what are the different communication protocols, what are the different networking protocols, for storage what do you use, for analytics what do you use, what are the different options. So all of these, so this is the overall idea of Internet of Things, right? So these are what has been covered in the entire course. So now let me take up the questions. We have few. How should I prepare to be a computer scientist? I am not sure, it's a very generic question. How you are going to prepare yourself as a computer scientist? I am not sure what your background is. If you are already in a computer science degree program, then and if it is an undergraduate degree program, then already you are taking courses that will give you the foundations in computer science. So there will be core courses in your university, there will be some elective courses as well, and if your university allows you, there are so many different attractive elective courses that are possible. Many of them are already available through NPTEL. IoT, for example, is one of them. Like this, there are so many other technologies that have also become very popular at present, like cloud computing, blockchain, artificial intelligence, machine learning, deep learning, quantum computing, like that. So many different emerging technologies or popular technologies are there at present. So you should, apart from your core courses, and if you have a choice for taking different electives at your university or outside or through these open courseware forums like NPTEL, etc., what you could do is take these courses in the cutting on these cutting edge technologies, right? And that way, and it also depends on what you would like to do in the future. As a computer scientist, there are so many different options that are there. What I told you are mostly application oriented, flavors of computer science. There could be, like, in case you are interested for the theoretical aspects, there are so many different avenues for theory as well. If you are interested in the in the hardware or architecture, computer organization aspects, there are so many different options that are there. So like this, so you have to make an informed decision. Maybe you can talk to your faculty advisor at your university to get more idea about what are the different options that are there for you to build your career in computer science. So next question is, which MTech course after BTech EC for IoT? IoT is interdisciplinary, and I think that is something that you have realized by now. Very much interdisciplinary within the electrical sciences as well. IoT, you will find researchers on IoT from all kinds of disciplines, core electrical, electronics and communication, computer science and engineering like me. People from instrumentation also take a lot of interest in IoT. Even mechanical, so to large extent, because when you are talking about robotics, etc., there are a lot of people from mechanical who have interests in this domain. Which MTech course, it depends, and I'm not sure about what are the different MTech courses specifically focused on IoT that are available throughout the country. I'm not very sure about it. What are the different courses that are available? You could check it out. If I would suggest that if the university has a good reputation, if you find that there is an IoT curriculum, MTech specifically, MTech IoT curriculum, then you could consider taking it up. So IoT is something. Another thing that I would that might also help you to take a decision is, IoT is something that is emerging at this point, right? So you have to think about what you want to do, whether you want to do an MTech in a generic discipline, or you want to do it specifically focused on some technology, whether it is MTech in machine learning, MTech in AI, MTech in software engineering, MTech in IoT. So you have to think about which one, what you want to do, whether you want to do a degree on some broad discipline or some focused topic, right? The choice should be yours, and it also depends on your interests, the prospects that are there, and so on and so forth. So basically, depending on these different factors, you have to make a choice for yourself. The next question is, practical sessions on cloud computing need to be more detailed. Some of the steps are confusing. Okay, good point. There is at least one course on cloud computing that is already there in NPTEL, right? And that particular course is focused on cloud computing, right? This particular course, the focus is not cloud computing, the focus is not AI, the focus is not ML. So if you are thinking that by doing this course you will learn in detail any of these technologies, then that is not going to happen, right? So that is not going to happen. So what you have to do, so what we are trying to do is, we try to expose you to what are the different tools and techniques that would be used to build IoT systems, only to expose you, not to make you an expert, not to give you detailed knowledge also, because if we have to give you detailed knowledge, then it will become a course in cloud computing by itself, right? And we will not be able to cater to the specific requirements that were given to us in terms of fulfilling or abiding by the course objectives. So basically, so if you have specific interest, now that you have got some exposure to cloud computing, what I would suggest you to do is to do the course on cloud computing available in NPTEL or elsewhere, and I believe that in those courses or through these courses you would be able to get more hands-on experience about and in detail about the different options, different things that you have in cloud computing. But I hope that you have understood some of these basics of cloud computing. That is most essential. I have seen students who have done courses in cloud computing but have not understood what cloud computing is, and that is what is very sad, right? So I hope that you have understood the basics of cloud computing. That is very fundamental before you jump into anything advanced. Next question is atmospheric change sensing using IoT. Atmospheric change sensing. So I think you want to say climate change, etc. I think that is what you are targeting. So there are so many initiatives on climate change globally, not just today. It has started, like even 10 years back. There are a lot of initiatives on climate change. In bits and pieces, there are so many different things that are happening, so many different initiatives, so many different projects have been launched, right, on climate change. IoT sensor networks are being used in this domain, and like I will give you a small initiative towards this. In IIT Kharagpur, we have a project, a multidisciplinary, multi-departmental big initiative on air quality monitoring using IoT, right? So we talk about over there the use of suitable materials, nanotechnology, coming up with nanosensors, then the networking and the communication aspects of the sensors, cloud aspects, fog aspects. It's a full-fledged program which is talking about air quality monitoring. So this is only air quality monitoring. When we talk about climate change, experts working in the domain of climate change, they know of the different other problems in climate change, right? So I am not an expert, so I do not know, but this is a small initiative that we have taken, but it's a big project because the problem itself is pretty big, and like this, if you do little bit of research in the internet, you would be able to find that there are so many different initiatives broadly catering to the objective of monitoring climate change. Any other question? Feel free to ask if you have any other question. So in the meantime, let us go back to cloud computing, right? So somebody was asking about cloud computing. So I will just take this time, this buffer time, to see whether you have some basic understanding about cloud or not. Already, we covered a couple of these different things in our lectures on cloud, but I am going to ask, I am going to discuss a few more. So when we talk about cloud computing, as I said before, in the lectures, that cloud computing is about having computing facilities as utility, right? So what is this utility? Utility means utility computing. So that means that the way you have you have electricity as utility, water as utility, and these are like metered services, right? And if you have to use electricity, if you have to use water, you really do not need to understand how electricity is getting generated, what is the entire process, etc., etc. So you have certain requirements, and you subscribe with the with the service provider about what sort of electricity services you need, and correspondingly you will be hooked up to that corresponding network, electrical network, that is provided by the service provider. So, as a user, you do not you have certain requirements, and you do not really need to know what specific you do not need to know how that particular utility is being generated, etc. So, you will be you will be offered the services, but then based on the units of usage you will be billed maybe at the end of the month, and then you will have to pay that corresponding bill. Now, cloud computing also is very similar. So, people thought that in the same way as we have electricity as utility or water as utility, could we also have computing as utility. So, I have certain computational requirements at home or in the workplace. So, I do not really need to go and buy infrastructure, software, platform, etc., etc. I have certain requirements. So, I will be simply registering myself through certain maybe web portals, etc., and then I will be making the payment, and I will be starting to use those services. It could be also that I use the services first, and then maybe I will be billed at the end of my use, or maybe after certain duration of time. So, like this the process continues. Okay. So, cloud computing, there are different models of cloud computing. The core traditional models were infrastructure as a service, software as a service, and platform as a service. So, in infrastructure as a service, you talk about having the computing infrastructure itself, right? Whether it is the CPU, whether it is the memory, whether the disk space, etc., etc. All of these, if you have certain computational requirements, you will be given these without you having to know what where your program will be executed, where this computer is going to be, etc. You have certain requirements, you are given an interface, you will be executing it, right? And the way you will be given is that you will get a feeling that you have exclusive belongingness of the resource that is given to you, right, exclusively. So, this is how this infrastructure as a service works. Similarly, the software as a service, there are so many software services that are available through cloud based technologies that are there. Similarly, platform is mostly like development platforms being offered as services. So, this is being already used. So, in the meantime, another question has come. IoT in space missions like Chandrayaan, right? So, now everybody wants to be a space scientist. So, Chandrayaan is one. Like this, there are so many space missions that are being initiated in our country and abroad also. So many things are there, and I think after this recent Chandrayaan thing, there has been a enormous growth of interest among everyone on the space technologies, right? So, let me try to answer this question. IoT in space, very much. So, when you talk about unmanned initiatives, very much, right? So, Chandrayaan was unmanned, right? So, there are so many, I do not know because I did not design Chandrayaan, but people who did, I am pretty sure that they have used lot of sensors, different types of sensors, different types of communication between these different sensors, which are part of the same spacecraft or maybe for long distance communication, etc. So, it is a complex thing. Delay tolerant network probably is something that might have been also used because when you talk about space communication between the earth and the satellite, there is so much of latency. So, when you send a signal pulse from the surface of the earth to that satellite and that satellite responding back, so what happens is you have lot of propagation delay, right? So you need to have protocols that will withstand that propagation, long propagation delay, because your regular internet based protocols will not be sufficient. So you need to have delay tolerant protocols, right. So delay tolerant network is something that is popularly used whenever you have systems where delays are considerable, right. So you send some request, to get the response back it will take a lot of time. So in the meantime it should not happen that acknowledgement has not come or whatever, and you think that there has been some congestion or whatever. So internet based protocols are not suitable. So delay tolerant communication mechanisms, sensing, actuation, communication between these different sensors, robots, communication between these different robots. So all of these are different aspects that could be used to build spacecrafts basically, and even for space communication also many of these things could be used. So what specifically Chandrayaan used, that I do not know, right. So that basically whoever were involved in that team, they would be able to answer, right. IoT in real time traffic management, very much. IoT in real time traffic management, very much. Okay. So these cameras, right, when we talk about traffic management, one of the important technologies is surveillance, right. So cameras fitted at different traffic intersections, road intersections, right. If somebody violates some rule, maybe the camera clicks and takes the picture of the license plate. In Delhi, I have not experienced, but what I have heard from my colleagues is in Delhi it is already operational, probably in many other cities also it is there, that if you violate some traffic rule, then after few days or maybe within few hours, maybe I do not know exactly. So you get you get the evidence of what you have done, and then you will be fined for that particular violation that you have committed, right. So this is also an example of IoT only, right. And IoT in surveillance in general, there are so many aspects. One of these is one of the very interesting ones, and a very challenging aspect also is the network of cameras, right. It is very challenging, network of cameras. So basically we are not talking about one camera, but different cameras working together in order to accomplish certain objective. That objective could be to track, to track in the case of traffic, maybe to track the violator, where the violator is moving with time. So these cameras will have to correspond with each other, not like sending it to some human being. So human being will then actuate another camera. So that is all going to be manual, right. So in most of these IoT, basically you have minimal manual intervention. So traffic management, yes, traffic lights, smart traffic lights. So these are all very, if you just do little bit of search in the internet also, you will find lot of initiatives on many of these different issues, right. So smart city issues, so traffic management, congestion on the road, surveillance using cameras, then so like this, actually there are so many different things that are there. The interesting part would be that doing everything in an unmanned autonomous manner with minimal human intervention, doing everything, and to reduce the time to decision, right. So basically what happens is you take the, let us say, the photograph, right, or something, but then some processing has to happen, and based on the findings, you will have to inform the corresponding person, or you have to actuate some other device and so on. So the time to process, time to decision, minimizing that time to decision is very important, particularly when you are talking about real time tracking, real time monitoring, real time management of whatever, whether it is traffic or anything else, right. So very much into it. Any other question? So, if there is no other question, I will just wait for another 30 seconds. If there is no other question, maybe we will stop for today. Very good question, very interesting question. What motivates you to do research in IoT? Very interesting question. I never thought about it explicitly until you asked me today. So, I think one of the prime motivators of anyone to work on anything which leads to lot of encouragement, then success, etc. One of the important things is basically liking it from within, right. So, that means that internally you have to have a strong liking. Now, networks, communication, etc., these are certain things which have been my bread and butter since long time, right. IoT basically came into picture maybe in the last 7-8 years or so. It has been popular. So, I have been working with sensor communication, etc., even before that. So, there is a long history due to which I developed interest in the different constituent technologies for building IoT. So, this is how developed interest in IoT. And thereafter what happened is, when you are working in a particular area, you are able to solve certain challenging problems. So, you might ask that what are these challenging problems. So, for this you will have to go through my research papers, Google Scholar or somewhere you go, you will look at my Google Scholar profile, you will be able to find all the publications. Look at the publications that are there in the last 10 years maybe, or maybe even less, last 5 years. Have a look at the publications that were there in the last 5 years, 2000 let us say 14 or 15 onwards. You will find that different aspects of IoT I have worked on, and so there are so many different challenging issues that we have addressed. You will not be able to believe until you have gone through these research papers and you have tried to understand them. And the good thing is that once we solve a particular challenging issue that nobody else in the world had addressed in the past, and we have done number of them in our lab, and so the good part is that once we do it, that gives you an encouragement, right. So, it is a problem, an unsolved problem that has been solved, you get an encouragement, and that basically motivates you to work on more such issues and so on and so forth. And then you keep on, you get publications in prestigious venues, IEEE, ACM, transactions, etc., beautiful conferences. So, once you get these publications, you get encouraged further, right. And at the same time, that is also there that IoT is a hot technology, right. So, and it is a technology that is very powerful also, and there are a lot of funds that are available globally for working on different projects on IoT. So, all of these things, it's a very encouraging ecosystem working on IoT, right. So, all of these taken together has motivated me to work on IoT, but maybe there are a few other aspects also. You have asked a very generic question, but a good one. So, I have not thought about this thing before until you asked me today. Thank you. Next question is challenges and future research area for WSN in smart cities. So many different, all of these, you look at the slides that I have on smart cities, right, smart cities and smart homes. So what you have are all networked sensor nodes, right. So that means that sensor network, right. So so many different things are there, whether it is transportation, whether it is parking, whether it is healthcare. So many different networked sensor nodes, concepts of network sensor nodes are used, wireless sensor networks are used. So in smart cities, so all these different domains in any city, whatever is there, these different domains you will find that these are all different problems that that could be worked on. You could use sensor technology, you could use network sensor technology to work on them, to build solutions, better solution, improved solutions to address those different problems that are there. So detecting and alerting mechanisms for tigers using digital image processing. Very good. So I think what you want to refer to is wildlife monitoring, right. So digital image processing is one thing, for wildlife monitoring IoT technology has been used by many people. IIT Delhi also has some project on this thing, what I have heard, so basically, so what they do is different wild animals, tracking their behavior around their habitat, etc., etc. So all these things you will find a lot of projects on wildlife monitoring. Digital signal processing, yes, you can use image processing in many places. You use one camera or many cameras, computer vision, multi-camera, fusion of data coming from all of these, making sense out of them, mobility, tracking, digital signal processing comes into picture. So somebody has some big project idea on IoT and you want to discuss with me in private, right. So if you have to discuss with me in private, you send me an email, and my email addresses are all available public. So everything is available publicly. You send me an email and then we'll take it up from there. Okay, so I think we'll stop for tonight, and so I wish all of you good luck with your exams, and I hope that before your exam you go well prepared to the exam. So type of questions are typically multiple choice type question that are typically asked. So you should go well prepared to the exam, you should score well, and if you still have any question you could ask. The best thing is to ask in the forum, and somebody will respond to you. And if you still, after the course, if you still need to connect with me, there are so many students every time they connect with me for different reasons, right, not just the subject matter knowledge, but also for different reasons people connect with me. So if you have any such requirement, I welcome you to contact me. Even after the course I will be available through email mostly. So with these few words, I would like to stop over here this particular session. This was the third session of interaction, and I wish you all the best. I wish you also that you carry on different projects, different initiatives. You try to build your capacity on IoT. If you are a teacher, in your university, you could try to launch a course if it is not already there on IoT. You can take help of our NPTEL course to launch that course. Based on the NPTEL course, you could build it. You could even call me. I am serving in many universities as an expert to their courseware design. So, like this, you can try to get involved on IoT. I hope that after the course, you do not get involved with IoT anymore. I hope that you have got sufficient interest to continue further with IoT. IoT in terms of teaching or in terms of research projects, etc. There are ample opportunities, and just go through my profile. You will get some ideas. If you search in the internet, you will be able to get many more ideas, right? So, try to stay in touch with IoT. This is what I would say, and wishing you all the best. Do well in your exams. Thank you.